just let me just confirm. We'll go to the channel. Okay, welcome everyone. I see that I'm live. Um, this is our night to just prepare for the exam. Okay, Emath 301 exam, and I'm going to be using assignment 1, test 1, assignment 2, test 2. Those are the things I'm going to be using. And I want you to solve all the questions that are going to come in tomorrow's exam that are going to be doing everything to do with differential equations, whether they are partial or whether they are ordinary. We should be able to do them no, with no problems at all. And then we'll also do anything to do with, okay, we'll do the past series as well. Then we just make sure we're good. These are the things that we're going to be polishing up. So I'm just going to be going round up through everything, that I'm hammering in the things that I know you are going to need to know for or whatever method we're going to be doing, and then we'll see how it goes. So there are things that I'm just going to follow the order. So for the first 30 minutes, it'll be some things that you probably have seen in test 1 or assignment 1, and a lot of you might be knowing already, but I'm just going to go through them again to make sure you're confident. We do them again for everybody. Nobody's going to be left behind. So we're going to be doing, this is easy stuff. We're going to have four methods to do for this assignment 1 and test 1, which we must be very, very perfect at. So if we go through assignment 1, when we go through test 1, you must be doing with me. If you have done assignment 1 properly. So when we're now doing test 1, you must be going 1, 2, 3, 4, 5, all the questions, the four methods that we're going to be doing. Then when we go to assignment 2 and test 2, again, we're going to be doing, but in there we're doing 3. Okay, it's just 3 main methods that you have to know for partial, when we're doing partial differential equations, and we see how it's going to go. Sorry for the background noise. It's going to go down. It's just a little bit of movement, but it won't be for forever. Are you ready? Let's start. We'll also do theory questions, but I think that's the that's the last thing I'm going to do, the theoretical questions. As for now, we are starting with the calculations. Let's see how it goes. So here it's going to go. Here is the assignment 1. It's a little bit of repetition for some of those that did with me last time. But here's going to be your assignment 1, and we are focusing on these big questions. 19 marks. 19 marks. 19, okay, no. Yes, we want to solve this one where it says solve the following part B, and we want to do this one. So 22 mark 1, which is number 4B. This is going to be the differential equation method 4. Okay, this is going to be differential equation method number 4. Remember, I said there were 4 methods for this one. And in here, solve the differential equation, then they give you this. This one is going to be, again, for 19 marks, this is going to be method 3. And it's 19 marks, right? And then we're going to have 2B, which is method number 2. And I want us to talk about it. We're going to talk about this guy in a way and see what you guys have to remember from him. So there's going to be method 2. And then we are going to have number 1B, which is going to be method 1. So I want to polish you up to make sure that you are definitely going to get it correct. You know, if you maximize on the things you know, if you maximize on the things you do know, to make sure all the differential equations you can solve, come rain, come sunshine, come thunder. If you're able to solve all the differential equations, you're fine. Don't worry about the other things, the Cauchy theorem, Legendre's polynomials, these other things that are at the end, vectors. Don't worry about theorems and all these. Those type of questions are not going to be your stronghold. If you know them, it's good. But even if you don't, if you know that all differential equations, whether they are partial or whether they are ordinary, you're going to solve. In assignment 1 and test 1, you are doing what we call ODEs, which means ordinary differential equation. You're doing an ordinary differential equation that is for assignment 1 and for test 1. And they are finishing here. So at the end of assignment 1 and test 1, we will be done with them because you only have 4 methods to know. Then when you now go to assignment 2 and test 2, you are now doing partial differential equations. And they finish. They're done. So any question that comes in the exam or whatever has to be like those. If I'm going to look here, so remember we said you have 4 questions, which is 4 methods. If you know these 4 methods, you're strong. You're strong. If you know all these 4, you're going to get a question from it. There has to be a question coming from this. Then from the stuff that comes, you're going to have 1 or 2 questions that come as well. So you know you're guaranteed 3 out of 5 questions or even 4, depending on how it's going to be structured. So let's see how it goes. Here's number 1. It says solve the. So here's how you know. What you have to know is how do you recognize the 4 methods? How do you recognize so you know what to do for each method? So here we can just say the 4. So we start with that is what we are doing here. We'll talk about the partial differential equations when we are now learning for test 2. So we have ordinary differential equations. Let's put the 4 and you should know what to do for each. So it's going to be ordinary differential equations. So ordinary differential equations, we have the 4 of them and we have 4 methods that we use to solve. So ordinary differential equation number 1, method number 1 of solving them is going to be method of separation of variables. I'm going to show you what comes for partial that it will help you see that it is not this one. You have separation of variables, that's method number 1. Method number 2, you have what we call the integral factor. So put this. Method number 2 is going to be the integral factor, which is going to be the second method of solving these ones. Method number 3 here is going to be, we can just say you'll be solving the homogeneous, second order differential equations, okay? Second order differential equations. Homogeneous means equal to 0. So if here you are just going to say this is going to be equal to 0. And it will be second order. We'll talk about it. For this one, you'll be using what? What do you use to solve? I can now put in brackets to say you're going to convert to D operator form. You just convert to D operator form, then auxiliary equation. So write that auxiliary equation. This sounds like there's anything, but this is just nonsense. This is easy. Then you're going to pick from 3 possible solutions. So you just you pick from 3 possible solutions, then we can say you are going to find constants. So here, this is going to be what we are going to be doing. It's when you have homogeneous second order. We'll talk about it. It's one type, and this is just going to be the step. This is very easy. You're going to now do the 4th one, which is going to be non-homogeneous. So step number 4, this is going to be non-homogeneous, and this is going to be non-homogeneous second order. There are things that you should just do. There are things that you should just do for these things, then you should be done. Non-homogeneous second order, for here you're going to be knowing, and remember they say they're not going to give you the particular integral table. So for this one, be careful, because you're not going to be given the table that is going to be the table that gives you a lot. You're not going to be given the table that helps you to find. You have to know some things off of your head. So this one is the one where you say to get y, you're going to say y is going to be complementary function plus particular integral. And complementary function, you find it using the steps above, which is for homogeneous. Then particular integral, you have to remember the table. So you just have, for this one, you have to remember the table. And we don't cram the table. What we should remember is what to do for each. You can remember it without having to try and cram it as a table. There are some things that you should just remember to say, oh, when I get it with a sine, I do this. When I get it with a polynomial, I do this. When I get it with an exponential, I do it. When I get it when they are adding, which is the common one, where you get them adding, you should be knowing what to do for that situation. It normally comes. We'll talk about it. basically, if we're able to do this, we should be. And I'm going to be practicing with you using questions from the assignment. Then we should do questions from the test one together. You must be able to solve it because you'll be knowing what it is that you do. So let's quickly go through this. What I want you to know is that these first two things are going to be for first order differential equations. So let's start. First order, that means here, put it. It means only dy dx is there. So if you are going to get a question tomorrow and it's a differential equation and it only has dy dx, the good thing about it is method number one and method number two, they actually tell you what to use. So it could be separation of variables or it could be the integral factor. Okay? It could be separation of variables or it could be the integral factor. Method number one or method number two, they are very good because they actually tell you what to use. They'll say use separation of variables or they'll say use the integral factor. So this one is not hard and you just go ahead and you do that. So let's go through it and let me show you. Here is going to be a question. They're saying solve the following using separation of variables. Oh, so separation of variables, we are going to be able to do it. And then they say solve the following by finding the integrating factor. By finding the integrating factor. So this again, you see, oh, so for these two, I'm fine. I should be able to do it. Let's quickly go ahead and let's do it. And let me show you where the main thing is going to be for this, especially for the integrating factor one. I want to show you where the main thing that you must remember from it. Okay? Let's start with this question which says, I want you to know that method number one and method number two are almost going to be the only ones where you actually have to integrate. You're going to have to integrate. So you have to be good at integration for this. For these other things, method 3, method 4, we are going to rarely integrate anything. We'll be just using tables, combining things, whatever. So it won't be any integration. So how can you forget? How can you struggle with things where you won't be integrating? The one where you integrate 1 and 2, that's where you gotta be careful. You gotta be good at integration a little bit, but they won't give you very hard ones. So let's start with this method number 1. It says 1 minus x squared. I'm going to be solving. So we are going to have it. Let me underline here. And the first method, so we're going to say method 1. Here is the question, and let's just see what we're going to do. We browse through it very fast. 1 minus x squared dy dx multiplying blah blah x y minus 5 is equal to 0. So 1 minus x squared dy dx, then it says plus 2xy is equal to x. Is that the one? No, plus x multiplying y minus 5 is equal to 0. So plus x multiplying y minus 5 is equal to 0. So when they just say separate the variables, it's self-explanatory. Separate the variables just means take everything with x to one side, everything with y to one side. So this is what you're going to do for this one. This one is going to be very easy. Everyone can do the very first part. You just have to be careful when you're integrating. Make sure you don't make a mistake when you're integrating. So for here, I'm going to see that I have my dy dx in the numerator. So I'm going to keep it on the left-hand side. And then I'm my dy. And I'm going to take dx to the right, which means everything with x has to go to the right because it has to go to the side where dx is. That's basically what happens. So you'd say, okay, not even a problem. If I start by taking this, I'll start by taking this because it is adding itself. I take it to the other side. You have 1 minus, because you must first isolate. The thing with dy dx should first remain alone before you try separating variables. The first thing you do is the thing with dy dx should stay alone. So this is going to be equal to negative of x multiplying y minus 5. This is what happens because they go to the other side, then they'll have a negative in front of them. Now what you're going to do, we said that everything with y has to go to the left-hand side because that's where dy is going to be on top. Then dx will go to the right with everything with x. So first of all, I can start by taking dx itself. I'll have 1 minus x squared dy is going to be equal to dx is dividing, goes to the other side, it will multiply. So minus x multiplying y minus 5 of dx. Now I'll take this y minus 5 to the other side. It will go and divide because it is multiplying. 1 minus x squared will go to the other side. It will go and divide again because it is multiplying. So I'll end up having 1 over y minus 5 dy is equal to negative x all over 1 minus x squared, and this is going to be dx. Once I have it like this, the things with x on one side, the things with y on one side, then I can start to integrate, right? Then once you have it like this, you can integrate. So I'm going to say the integral of the left 1 over y minus 5 with respect to y is equal to the integral of everything on the right. I can take the minus outside. I would have x over 1 minus x squared with respect to x. This is very easy. Now when I have my fractions, here this one for 1 over something is very easy, because when you're integrating it, you just get ln of whatever the denominator was going to be. So it's going to be 1 over y minus 5. What do I get? It'll be just ln of y minus 5. Okay? And this is going to be equal to, I don't care where I'm going to put my constant of integrations. I could put it on the left, I could put it on the right, it doesn't change anything. This is going to be, for here I'm integrating this where I have x and the bottom is 1 minus x squared. So what I can do is I need to make sure that the top is going to be exactly the denominator of the bottom. Then I can just say ln of something. So here I can say that if I differentiate the bottom has an x squared. If I differentiate the whole of the bottom, let's say you are differentiating 1 minus x squared. What do? You differentiate 1, it becomes 0. You differentiate x squared, it becomes negative 2x. So in other words, on the top, I want to have a negative 2x. So I'll put back the negative, leave it there. But then I need to change it to a 2x. To change it to a 2x, what do? I multiply by 2. Then what should I do outside of the integral? To reverse what I have done, you divide by 2 outside. So that means outside, because you should reverse what you have done so that it's like you have done nothing. So it will be half integral of, now this becomes negative 2x over 1 minus x squared. This trick, you're going to do it over and over and over again, where you make the top be exactly the derivative of the bottom. Because when the top is exactly the derivative of the bottom, we will not have to do any work in integrating. We'll be knowing what the answer is. If the top is exactly the derivative of the bottom, then you just get ln of the bottom when you integrate. So for here we had a 1 over, so yeah, it was just that easy. Okay, and because the bottom was not a y squared, it was just a y. So you just say ln of that. Here, because this was an x squared and there was an x at the numerator, you have to make sure that the numerator is exactly the derivative of the bottom. So that's what we did. You see it as this. We made it a 2x, and we should then divide by 2 outside to reverse that thing which you have done. So you now have it as ln of y minus 5 is equal to half integral of, now because the top is exactly the derivative of the bottom, we'll just say we don't have to do the integration, it's just ln of 1 minus x squared. Okay, if the top is exactly the derivative of the bottom, when you integrate, it will be just ln of the bottom. So it is ln of, what is the bottom? 1 minus x squared. So it is ln of 1 minus x squared. That's how you do it. And you have it like this. Now you can put your constant of integration c. Once you have it like this, you have to find the constant. You're done. But you have to find that constant of integration c. And the only way to find it is you go to now your, here. You go to your conditions. They said at x0, y is equal to 6. So we have x equal to 0, y equal to 6. So you can just come here and you say, let x equal to 0, y equal to 6. So you now have ln of 6 minus 5 is equal to half ln of 1 minus 0 squared plus c. So ln of 6 minus 5 just becomes ln of 1 is equal to half. Then this becomes ln of 1 again, then plus your constant of integration c. Is ln of 1 0? I think so. Let me just see. ln of 1, yeah, it's 0. So this is going to be 0 is equal to half by 0 plus c, which just leaves you to 0 is equal to c. So c is nada. He is nada. So we can now rewrite this because we know it's, so you're just going to say ln of y minus 5 is equal to half ln of 1 minus x squared. You're done. This is how you're going to solve by separation of variables. So method number 1, we are fine. You probably will get a fraction, and you have to make sure the top is exactly the derivative of the bottom if there are just some changes. Then you know that it will be ln of the bottom when you integrate that. And that's how you do it. And when you make the top be exactly the derivative of the bottom, you go to the top and you adjust it. Now when you adjust the top, you go outside of the integral sign and do opposite of what you have done. So we had to adjust by multiplying by 2. We went outside, we divided by 2. That is half. That half. And we cancelled out what we have done and blah, 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 blah. We found the constant. If I ever do a mistake in the stages, somewhere in the stage, don't worry about it. That's not it. That's not a big thing. The most important thing you have to be getting from here is the methods. Let's go to the second one, where we are now going to use what we call the integrating factor. I want you to be now ready for here, the integrating factor, because this is going to be something which I want it to be very, very, very important. And I'm going to go to do this question, and let me talk about it. We're now doing method number 2. So I'm going to erase after method number 2, so we go back to the top and we can keep writing. So method number 2 is going to be the integrating factor. Integrating factor. Okay? Now, when you're doing the integrating factor, there are 2 main things that I will need you to remember. You have to go into the exam remembering this. Like how you get a solution using it, and what the integrating factor actually says, because that's going to be very, very important. So the integrating factor says, here's what you'll be trying to get. It's going to say y(e) to the integral of p dx. Write this. This is going to be equal to the integral of e to the integral of p dx. Then we're going to say multiplying q. This is what the integrating factor is going to say. Y(e) to the integral of p dx is equal to the integral of p dx. Let me shade. It is equal to the integral of p dx mod e to the integral of p dx multiplying q. E to the integral of p dx, that's a big one. E to the integral of p dx. This side it is multiplying y. Here it is multiplying q, and it has an integration sign. There is an integration sign. Be good at that. So what you're going to have to find, let's talk about it now, because I want you to see what you're going to have to find, that we're going to have to put, to say, what is this? Because it's one thing to write this, but you want to know, what do you actually do? What are the important things? What are the important things in this thing? Because we have we have e to the integral of p dx. So I want you to know, pay attention to p and to q. Those are the big guys. If you know p and you know q, you can do this one. It's resting on your ability to locate p and to locate q. How do you locate them? We're just going to say here, whatever dy dx, but dy dx should be alone. Okay, dy dx plus py is equal to q. You should know that you should always have this form. So always have this form. I want you to write down, I don't even mind it if you don't write down the example. I don't mind. But this I mind, because this is what you have to actually remember. You have to make sure that your dy dx has nothing multiplying it. Sometimes they'll give you with a number. Remove that number, because you must have it in this form. Dy dx plus py is equal to q. You must have it in this form, and you must be able to identify your p and your q. If you have them, you are done. P is the coefficient of y. Q is going to be whatever else, things with x or whatever. Those are going to be your q. And we are going to put them into this, and we're going to find it. Okay? So let's do the question that you were given, and you guys need to see it. Let's do this question. It was number 2b, which was saying, find the solution, initial value. Once you see this keyword, integrating factor, once you see that, remember that you're going to have what? Y e to the integral of p dx is going to be equal to the integral of e to the integral of p dx multiplying q. We're going to have something like this. But remember, to ever have something like this, we need p and we need q. So for me to have p and q, remember, it is going to be dy dx plus py is equal to q. I should have this. Okay, that's what I should just have. Dy dx alone plus py is equal to q. Then I know that the thing that will be before y is your p. The thing that will be everything else, which is not, That's going to be your Q. And make sure it's on the other side of the equal sign so that when you're choosing it as a Q, you are choosing it with the right signs. You have to choose it with the right signs. And it has to be on the other side of the equal sign for that to happen. You understand? So I'm going to say, okay, no problem. What did I have? X squared minus 1 dy dx plus 2xy. So let's go. We're going to write that. X squared minus 1 dy dx plus something xy. Let's see. X squared minus 1 dy dx plus 2xy is equal to x. So it's going to be plus 2xy is going to be equal to x. So we have it like this. Now, we know that we must have it in this form. It's you writing in the exam. You know that you must have it in the form dy. For integrating factor, have it in the form dy dx plus py is equal to q. Now I'm going to ask you, is this dy dx? No, it's not. It has something in front of it. Get rid of that. Because it should be dy dx alone. So to get rid of it, I'm going to divide everything by that thing. So I'll end up having it as dy dx, it will remain alone. But here I'll have 2x over x squared minus 1 of y. Okay? Because the y will now remain. This is going to be equal to x over x squared minus 1. Everything is now going to be divided by x squared minus 1. Why? So that I have the dy dx alone. Now, once you have it in this form, I'll ask you, who is your p? P is going to be number before y. In this case, it is 2x over x squared minus 1. Who is your q? X over x squared minus 1. Really? Yes. So you can come below and write. Once you have this, write it to say, my p is equal to 2x over x squared minus 1. My q is equal to x over x squared minus 1. This is what I have. Is it not? Now, what am I going to get from here? Let's go and put what we need. Remember, we're going to need to have it as ye blah, 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 blah. That's actually how you get the answer. ye to the integral of p dx is equal to the integral of e to the integral of p dx times q. So now, what we need you to find is, find this thing here that you're going to be putting as the power. Find it. This is the integrating factor. So this is your solution. If you have done this, you would have found a solution. But you need to find what you're going to put as the power of e. And don't leave this integration sign. If you leave it, it's over. So integral of p dx is going to be this guy, which I'm going to put as the power. Integral of p. I found my p, I found my q by knowing the form. By knowing that this thing is in this form. For it to ever work, for me to find my p and my q, I put it in that form. I found p and q. Now I'm going to integrate p with respect to x so that I know what to put as my power. What is my p? 2x over x squared minus 1. You are integrating that with respect to x. That's the p, right? So you're integrating it with respect to x. What do you get? Now, this is so easy because you're getting used to it, where the top is exactly the derivative of the bottom. Because if I differentiate the bottom, let's differentiate the bottom, d dx of x squared minus 1. I'll get d dx of x squared is 2x. d dx of minus 1 is nothing. So, give me a sec. d dx of x squared minus 1 is going to be 2x, or that's 2x. So we can see that the derivative of the bottom is just 2x. Is it the thing which is at the top? Is it? Yes! It's the thing which is at the top. So I'm going to say, the top is exactly the derivative of the bottom. Oh, that's good. If the top is exactly the derivative of the bottom, then I'll just, when I integrate this, I'll get ln of the bottom, ln of x squared minus 1. This is going to be my integral of this. Then I can now go and put it in my, so I'm going to say ye to the integral of p dx is going to be equal to the integral of e to the integral of p dx multiplying q, which is going to be y times, what is going to be here, e to the this, we know it's going to be y e to the, what is the integral of p dx? It is ln x squared minus 1. This is going to be equal to the integral of e to the ln x squared minus 1, because we already found it, the integral of p with respect to x. Then this, we just multiply our q. And what is our q? X over x squared minus 1. So it's x over x squared minus 1. And remember, I want you to know that we say this with respect to x. Don't forget to put a with respect to x here. So it's integral times q with respect to x. So it's going to be with respect to x. We're done. Now you're just going to find, this is what we call the integral factor or integrating factor. That's what you do. The integrating factor is this thing here. We'll be using the integrating factor where you have the e to the p dx, whatever. This is the method. This is what you must know. You must know this thing, and you must know the form which helps you to find your p and your q. So now we can have e to the ln, e and ln will cancel. So the thing will just come down. So it will be y is actually multiplying x squared minus 1. You must know that. Because e, it's like you raise the power of e, then you ln, it's like you have done nothing. So the x squared minus 1 will come back. Then that's the same thing here. E to the ln is like it comes. So it's just the integral of x squared minus 1 multiplying x over x squared minus 1 with respect to x. It should become this simple. If you see it becoming harder and harder, something may be wrong. X squared minus 1 and x squared minus 1 will cancel. You now have y multiplying x squared minus 1 is equal to the integral of x with respect to x. So we can say y multiplying x squared minus 1 is equal to, you integrate x, you raise the power, divide by the new power like this. Then you can put your constant of integration c because you've done an integration. Then now you can use the conditions to find c, and you'd be done. This is how easy it is. You can even add the constant of integration after you have taken this x squared minus 1 to the other side. It doesn't even change anything. But anyway, even if I leave it like this, I come here and I'm going to have what? Let's go to the conditions because they were given in the question. They said let x be equal to 0, y equal to minus 1. So x is equal to 0 and y is equal to minus 1. So we're going to have to put that. X 0, y is minus 1. So you're going to come here and say let x equal to 0, y equal to minus 1. Okay. If you wanted to make y the subject, it doesn't matter. You are still going to get another c. So you would have said y is equal to x squared over 2 multiplying x squared minus 1. We can just say plus another c, which is a bigger c. Eh? You can put the constant after you have made y the subject. It doesn't change anything. So you now say let x be equal to 0, y equal to minus 1. If you put that, you'd have now minus 1 is equal to 0 squared over 2 by 0 squared minus 1 plus c. So you have minus 1 is equal to 0 squared is 0 over 2 by 0 squared minus 1. That's 2 by negative 1. Then plus c. So you end up having minus 1 is equal to 0 over something is just a 0 plus c. So minus 1 is equal to c. We get c being equal to minus 1. So you have y is equal to x squared over 2. It's x squared over 2 multiplying x squared minus 1. 2 multiplying x squared minus 1. Then minus 1 like that. This is going to be your y, and you are done. We say to you, well done. That's fantastic. So the first two methods we're done. We should be able to do the questions in the test. And what we're going to use to test ourselves is I'm going to do all the methods using the assignments. So that means I'm going to also go to assignment 2 and do the methods, and then we can start doing the tests together whilst you have all the methods in your head one time. It's an asset test to see how much you actually remember of all the methods, right? That's fun, right? So from here, I'll use assignment 2 to teach you the other 3 methods, yeah? And then we can go ahead and we see how it goes. Can I erase? I'm now going to erase this, because these 2 we are done. Remember the integrating factor please, please remember this thing, and please, please remember this form. And you are done. That's everything you need. The other things, you get them along the way. And you can see that for these, we were actually integrating. For the other things, no. We won't really be integrating anything. We won't really be integrating any single thing. We won't be integrating. Really? Yep. It's just solving quadratic equations, using the quadratic formula, doing other things, but actually not integrating. So, it's not that hard. Let me take a very big eraser so that I don't waste time erasing. Then I'm just going to go. I don't have to erase this part. Okay, we are back. And we're doing the third and the fourth methods now. Homogeneous second order. Homogeneous means it's going to be equal to 0. And non-homogeneous. Let's see. This is going to be very important because it actually is part of the reason why I started with this and I did not go to the thing. Because I know probably a lot of people would have wanted me to do things from assignment 2 and test 2. But the things in here actually make you do that better. So there are going to be some things we need from here in the other one. And that's why I started with this. Let's start. So what are we going to have? Now, remember, we are no longer doing things that have only dy dx. Now we're actually going to be doing things that have the second derivative, d2y dx squared, whatever. But I want you to know, I've never ever seen something this easy. It's outrageous. It's a joke. So for method 3 and method 4, you're going to have the second derivative. And in here, they will actually not say to you, use this and use this and use this and use these. You are going to have to remember the things that are important on your own. You're going to have to remember on your own. So let's see the things that are going to be important for the questions that are about to come. And we should recognize the questions and know the important things that you know and use them. So the things that the things that are going to be important for you to know, please put. Can you put this? I want you to put the 3 types of solutions. Okay? 3 types of solutions for homogeneous. For homogeneous ODEs. This one you have to know, okay? For homogeneous ODEs. The 3 types of solutions for homogeneous ODEs. Let's put them. Number 1. So, if M1 and M2 are real and distinct. This is the what I'm showing you is the important things, the things that you actually have to remember. The other things, don't worry. The other things you remember, it's like common sense when you do the question you see. But here, this is the thing you can't afford to let it slip. It will cost you. The types of solutions are, if you have M1 and, so it's going to depend, we're going to solve an auxiliary equation. That one everyone can do. When you get the solutions, now you should know the types of solutions. You look at M1 and your M2, and this is going to be important again for things that are in assignment 2, as you will see, don't worry. But here you're going to look at your M1 and your M2, and they're going to tell you what Y to choose. So if M1 and M2 are real and distinct. Distinct means what? Different. They are real and different. They are normal numbers. Whether they are negative or positive, we don't care. But they are normal numbers. They are not complex numbers. They are normal numbers and they are different. So you're going to have your, in that form, when you have it, you're going to say, let me pick a crayon. It is refusing to write. Good. You're going to say Y is going to be AE to the M1X plus BE to the M2X. This is going to be how you're going to get your thing if you are going to have them be distinct and different. Then case number 2, if M1 and M2 are the same. If M1 and M2 are going to be the same, and they're going to be if they're going to be the same and they're going to be real. So let's say they're going to be the same, and in bracket we say and real. So you have M1 and M2, they're going to be the same and they're going to be real. So what you actually have as your Y is going to be, Y is going to be, okay. Give me a sec. What happened? So it is, let me see. Okay, I think you can hear me. Right. I was saying, sorry for the noise, okay? But it's going to be quiet, don't worry, in a short time. So you'd have it as Y is for this, when you now get your M1 and your M2 being exactly the same, so you're just going to say Y is going to be AX plus B. It's not AX plus BX or whatever. It's AX plus B. B is nothing. Because your job is just going to be finding the A and the B, so it's not. And it's going to be all to the power of MX. Then you move on. AX plus B. Then you're going to say E to the MX. There's always an E for everything. I don't know why it almost. So here it's going to be now when you have complex solutions. Let's see for for your complex solutions, they are going to be different. Don't worry about it. Here when we say the solutions are going to be the same, it's obviously they're going to be real. For complex, you're going to get them different. This is the thing to remember. Please, how to choose. If you don't remember anything, remember this. You should get then and write Y is equal to, if I'm going to have two different whatever, you say Y is going to A e to the M1x plus B e to the M2x, then you AX plus B, then E to the MX. Then you're going to say for complex solutions, for my complex solutions, you'll be having your M1 being equal to alpha plus beta I. Then M2 will be, let's say M2 will be alpha minus beta I. They are always like that. Complex solutions are always the same, but the only thing that will be different is the sign. Complex solution, here there is a plus, here there is a minus. In your complex solutions, this part which I'm putting in purple is called the real part, and the part which I'm putting in red is called the imaginary. So this is going to be real, then this is going to be imaginary. This is going to be real, then this is going to be imaginary. So here are the things. These are the things we have. Can you see them? Okay, so here we'll be saying I have a complex solution. So if you have a complex solution, how are you now going to choose your Y? You'd want to choose your Y. So you'd say, if I have my complex solutions, you're going to have Y is going to be, we first put this real part. A complex solution has a real part and an imaginary. Real part is the normal number. Then the number with the I is going to be the imaginary. So you take the real number first. It's going to be E to the alpha X. This is going to be the real part, right? Then you are now going to put the imaginary parts. Imaginary parts, where are you going to put them? Inside. And it will be now A cos beta X plus B sine beta X. There we have. Beta is going to be the number before I in the imaginary. We call it the imaginary number. The number with an I. We just take the number, we don't take the I. And we'll be putting it here. Okay? Alpha, so here you should know alpha comes here, beta comes here. The rest will be constants. You're going to have to find them. So remember this, please. Please remember this. Let's go ahead and let's do a solution. If you remember this, this is the most important part. If you remember this, then a second order homogeneous differential equation, which is a differential equation which has the second derivative and it is equal to 0, you can solve. If you know this, then you can solve. Because this is the hard part. Remembering solutions. People don't remember solutions. They don't remember the versions of y. If you know the three versions of y, the version number 1, version number 2, and version number 3. If you know them, that's what you should actually practice. To say, for this one, do I know the three versions of y? If you know the three versions of y, you're fine. You'll be fine. So, let's go ahead and let's now do the question. You go to the question now. You see the second derivative and you see it equal to 0. Remember, they won't tell you what method to use. They did when they were telling us integrating factor and separation of variables. But now they are not. And that is why we are hammering these things, because you must be able to, in an exam setting, look at a question and recognize what it is. So you look and you say, there is the second derivative. And this thing is equal to 0. So it is the one way I just have to remember those three y solutions. Like, it's the homogeneous, because homogeneous is anything equal to 0. And second order. So for this one, yuck. Light stuff. Let's go ahead and let's do it. Because I know everyone will remember the stages when I start to solve. The D operator form, auxiliary, everyone can remember that part. You should remember the solutions when you find your M. So here we have y prime prime plus 4y prime plus 5y equal to 0. So we have y prime prime plus 4y prime plus 5y equal to... You know, if you actually master these ones and you are 100% sure that you're going to get them, don't worry about the rest. If you're 100% sure that all the differential equation techniques in assignment 1 and test 1 and assignment 2 and test 2 as well together, if you're good, you're good. Be good. If you're good, you're fine. So it's going to be, okay, here I would say what we are now doing. So let's see, what we wanted to know was the three versions of y. But now we are solving. So when you are solving, you must just know that you convert to D operator form. So there's going to be the D operator form. Anyone can do this one. So you convert to D operator form, then you do your auxiliary equation, then you solve. The rest I know you guys are now good at. You do an auxiliary equation, then solve. Solve for M. The rest I know you're good, because once you get the versions for M, you're fine. You should now use one of the three conditions to find the y. So let's convert to D operator form. When you get this y prime prime, you're actually now going to call it as D squared. So you are now converting to D operator form. And when we say D squared, you're going to see it as well for the next thing. The things for assignment 2. When they're going to be writing, D squared, D squared is not D squared. It just means second derivative. Please master that. And when you're taking from D squared going back, you have to integrate, because D squared is actually second derivative. D is actually first derivative. So what we're going to say is this y prime prime is actually D squared of y plus 4, here it is D of y, plus 5y is equal to 0. Then we factor out the y. So usually when they write the D operator form, they would have factored out the y. So when you factor out the y, it becomes D squared plus 4D plus 5, and you factor out the y is equal to 0. This is what they call the D operator form. Now when you get to D operator form, you convert to auxiliary equation, which means remove D's and put M. That one is, come on, we're not even integrating. Huh? We're just putting D's and M's. How can you not do that maths? That's simple maths. So you're going to say, I remove D, I put M. It's going to be M squared plus 4M plus 5 is equal to 0. Okay? Don't worry about the y. Now, what you're going to do is, let's find the values of M. When you're finding values of M, always use the quadratic equation, right? So you should find A. A is the number before M squared, which is 1, with its sign. If it's positive, you put it as positive. If it's negative, you put it as negative. Then B is the number before M, with its sign, which is 4. Then C is the number which is alone, and with its sign, here it's going to be 5. So first thing you're going to get is B squared minus 4AC. What we are now doing is we are solving this quadratic equation. We put our A, B, and C, then we get B squared minus 4AC. So it's going to be B squared, what is B? 4 squared minus 4 times A, 1 times C, 5. So this is going to be 4 squared, 16 minus 4 times 5, which is 16 minus 20. Wow, the eraser is way too big. Let me reduce its size. You'd have it as 16 minus 20, which is going to be negative 4. So here we get our b squared minus 4ac. Now you're going to say m, the quadratic equation, actually says m is equal to, if it was an x, would say x, but here it is in terms of m. So for our maths, for the whole of this math tomorrow, it'll be just in terms of m. So you now say m is equal to, this one you have to remember, minus b plus or minus the square root of b squared minus 4ac all over 2a. It's unacceptable for you not to know it because it's going to make you not get the answer. And can you imagine failing to get the answer because you're stuck on quadratic formula? Really? So you're going to say m is going to be minus of b. What is our b? 4. So it's going to be minus of 4 plus or minus the square root of b squared minus 4ac. We got it already, and that is a negative 4. So the square root of negative 4 all over 2a, which is 2 by, what is the a? 1. So it's 2 by 1. So now you're going to have being m is equal to minus 4 plus or minus the square root of. When you have a square root of a negative number, what you must remember is I squared is equal to negative 1. So you are going to remove a negative 1 from there. So it will be negative 1 by, it's now positive 4. Then it is going to be all over 2 by 1 is 2. So you now have m is equal to minus 4 plus or minus the square root of. Negative 1 is what? It's I squared by 4. O over 2a is just a 2. Now what would you get? M is equal to minus 4 plus or minus. Here, square root of things that are multiplying, you get both of them. So square root of I squared is I. Square root of 4 is 2. So it's going to be 2i or I2, doesn't matter. Then it's all over 2. Here we have, and we can see, we can have our first m being m is equal to, let's go. It's going to be minus 4 plus or, let's put it, if we're going to say minus 4 all over 2, what do you have? 2 into 2, 1, into 4, 2, into 2, 1. You put it into both. So it's going to be, which, yes, you'd say minus 2 plus or minus I, which is going to be your m is actually going to be, m is equal to minus 2 plus I, or m2 will be minus 2 minus I. Here we have our m1 and here we have our m2. Now, what type of solutions are these? They're going to be complex. So if they're complex solutions, what did we say your y is? That is what we spent a lot of time doing. Y is going to be e to the alpha x. What is the alpha? The number. So it is e to the negative 2 of x. Then we go inside. We are now going to say a cos beta x. What is beta x? Beta is the number in here. So if you want, you could have said alpha is equal to negative 2 and beta is equal to, beta is going to be the number before I, which in this case it's a 1. So it's a cos x, alpha x, plus b cos sine beta x as well, which is just b sine 1x, which is just an x. Once you have it like this, there we go. Here is going to be your y. Now you should find your a and your b. You say, let what? This is amazing. You've done very, very good work. Oh, the battery for this thing is low. Give me a minute. The battery for this thing is low. Which means the audio quality will go down because I kind of have to disconnect the microphone to connect the charger. So, but I'm sure it will still be fine. Let me do this. Right. I think you guys can hear me now, so I fixed it. Let's continue. What I was saying was we now go and get the conditions. They gave us conditions, surely. What were the conditions for this one? X0, Y0, and dy dx equal to 2. So when x is 0, y is 0, and dy dx is 2. So in other words, we can say that we know that when x is 0, y is 0. And when x is 0, dy dx is a 2. So let's do that. So what I'm going to say is, first I'll say let x be equal to 0 and y be equal to 0. So you end up having 0 is equal to e to the negative 2 by 0 multiplying a cos 0 plus b sine 0. Now this is going to be 0 is equal to any number to the power of 0 is, because this will actually be e to the power of 0, and you're going to have a cos of 0 is 1, so it'll be a by 1 plus b sine of 0 is 0, so it's b by 0. So it's going to be 0 is equal to any number to the power of 0 is 1, multiplying a by 1 is just a, plus b times 0 is 0. So a times 1 is a, so you can say 0 is equal to a. So there we go. We got our first thing. Our a is going to be 0. Hopefully you can still hear me. It looks like you can, because I'm monitoring from here as well. Now you're going to get your b, so we rewrite it again. We say, what did we have? We had y is equal to e to the negative 2x, which is e to the alpha x. Then we had a cos x plus b sine x. Now, what we actually do know is that our a is 0, so we can say y is equal to e to the negative 2x. Then we just have b sine x, e to the negative 2x of b sine x. Now, what do you actually get? Get your dy dx, because they told us what dy dx is. Get it. It is going to be, when I have these two things multiplying, how do I get? Because here we found a as 0, so that is why I made this be 0, so it's gone. So this e to the negative 2x will actually just multiply this. So now what would we have? We are trying to differentiate these two, and they're multiplying each other. So what do we use when you're differentiating two functions that are multiplying? This is an exponential function, and this is a trig function. So when we are differentiating two functions that are multiplying each other, we're going to use the product rule. Product rule says bring the second one. Remember, b is a constant, so we can put b outside maybe to first try to say y is equal to b is going to be outside. We have here e to the negative 2x times sine x. This is what we actually have. So we can say our dy dx, because b is multiplying, it will not go anywhere. The things that go are constants that add or subtract. This is b is a constant that is multiplying, so he doesn't go anywhere. So you're going to have it as, now you say this is going to be your u v. The product rule says bring the second one, the v, it's sine x. Multiply by derivative of the first. Derivative of the first, when you differentiate e, you first bring it as it is e to the negative 2x. Then you multiply the derivative of its power. The derivative of negative 2x is negative 2, like that. Then we say we say plus. Now what do we do here? So first we brought the first thing, which is sine x, then we multiplied by the derivative of the second. Now we bring the first, which is we brought the second, we multiplied by derivative of the first. Now we bring the first, e to the negative 2x, we multiply by derivative of the second. Derivative of sine x is just cos x. So this is what we have. And then we're going to have it as what? Dy dx is equal to, here you'd say negative 2e blah blah blah, so it's b multiplying negative 2 e to the negative 2x sine x, then plus e to the negative 2x cos x. Now we say let x equal to 0 and dy dx equal to 1. They said when x is 0, dy dx is 2. So we're going to put 2 for dy dx. So 2. Now we're going to say here 2 is equal to b multiplying negative 2e to the negative 2 by 0 sine 0 plus e to the negative 2 by 0 cos 0. What would you have now? 2 is equal to b is going to multiply negative 2 by, here we have, okay, anything by sine 0 will actually be 0, so this thing will become 0. Then you have now e to the negative 2 by 0 is e to the 0 by cos 0 is 1. So any number to the power 0 is going to be 1 as well. So it's 2b, 2 is equal to b multiplying e to the power 0 is 1 by 1, which is going to be 2 is equal to b. So here we have it. Now we can just write, we're done. So you are going to write y is equal to e to the negative 2x. Then in here we just say of b, which is 2, by 2 of b sine x, 2 sine x. And if you want, you can say y is equal to 2e to the negative 2x sine x. There we go. We have our y. And we'll be done. This is going to be how you solve for this auxiliary. It is all on you knowing the form of y to choose. Then we will find the constants. Constants, we will find them or they will find themselves. It's nice and easy. It's not even a complicated one. Okay? Now we have one more method and we're going to go up. We'll be saying this is, if we do this one more method, then it's going to be over. One more method for this test one and for this assignment one, which you then must be able to do from there. Test one, the whole of test one. Then we're going to do assignment 2. From there, you should be able to do test 2, and we'll see how it goes. I'll give you a 5-minute break because I want to do some. Then we can continue. So what is the time? The time is 8:57. We are resuming at 9:04. Ah, that's 7 minutes. 9:03. 9:03. Give me 1 sec. So. All right. Now let's go to this second one. So in this second one, you'll be given as a differential. Remember, trust me, when we do a situation, it will never come again and you do something else. Don't worry about that one. You know that anytime you are going to get the second derivative, okay, anytime you are going to get a differential equation and it has the second derivative, okay, and it is equal to, it just doesn't have the first, it has the second, and it is equal to 0, you use this homogeneous, okay? Just make sure you remember the y's, the different versions of your solutions. If you remember, you are fine. Just make sure you remember the different versions of y's, then you'll be good. Okay, so now let's see the other thing that I need you to see. We're now going on to the next level. If you're good with this and you say, for the one which is equal to 0, I'm good. Now we are going to do one where you will have second derivative and then it will not be equal to 0. So you're going to have the second derivative and it will not be equal to 0. Remember method 1 and method 2, we were doing integrating factor separating variables, but for that one there is no second derivative. Method 3, which we just did, you have second derivative and it is equal to 0. Method 4, which is the final one, when you're good, when you're able to do this, we say, normal differential equations, the ordinary ones, you are done. You know all of them. If you're able to do this one, we'll say, you know all the ordinary differential equations. It'll be now just the partial, which are the things for assignment 2 and test 2. So let's see. How do we remember this? We don't cram a table. That's dangerous. We're not going to go that way. What we are going to do is, let's now do one where we said, remember, there is going to be the second derivative, and it is now going to be equal to, we say it is non-homogeneous. It is now going to be equal to something which is not 0. So you're going to have the second derivative there, and then you are going to have that thing with the second derivative not equal to 0. It won't. It will not be equal to 0. What should you do? You will calm yourself down and you say, time for me to cook. What you are going to always do is, you are always going to look at what it is equal to. Okay? So you're always going to look at what it is equal to all the time. Make sure that the things with x, you take them to the same side. Then you look at them. What is it equal to? So here are the things that you must know. It could be equal to a constant. Remember, it will be equal to, it won't be equal to 0. So it will be equal to something here, which we'll call an f of x. It will be equal to something that will be having an x. Okay? This is not going to happen. It's not going to be equal to 0. This is for homogeneous, we're done. We are going to be doing this, where your function blah, 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 with the second derivative, plus dash, dash, with the first derivative, plus dash, dash, y is equal to here. So we are always going to look here. Remember now what you're going to do to find the solution. You're going to do it in 2 steps, and I'm going to show you. But what I will need you to know is that in step number 2, you're going to have it as y is going to be, they say, the cumulative function plus the particular integral. So we're just, in other words, we're going to say y is equal to, what we actually write is y is equal to u plus v. So you need to find u and you need to find v. And you find them separately. You find them separately. How do you find this v? How do you find this v when you're finding them separately? First of all, what you're going to do is you are going to need to know the versions. So if f of x is equal to a constant, if f of x is equal to a constant, then you must know that your v will be k or your v will be kx. So guys, if f of x is equal to a constant, for v you're going to put k, not a number. You actually put k. Or you're going to put v is equal to kx. When do I use v is equal to kx? You use it if, in here, you're going to use it if 1 m is equal to 0, in, if, here. V will be kx
when you are going to get f of x, the other side, remember, you now have second derivative, blah, 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 is equal to, but it will not be equal to 0. It will be equal to something. So always look on that other side. It will tell you what to do. And that is what they're saying. We'll see with practice and you'll see how easy. If you master this, wow. If you master this part, wow, 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 you're done. If this other side is a number, a 5, a 7, a 9, a 11, a 10, then you're going to put for your v, which you are going to look for, you see how to look for it, but for your v, you remove v and you put a k, or you remove v and you put a kx. When do you put a kx? If one of the m's is 0. If one of the m's is 0, remember how we're going to find the m's. We'll be using the things which we learned above there, where you do your d operator form, auxiliary equation, you solve that for m. If you get one of the answers for m, if you get it one of the two answers being 0, then use kx. But if you get your m being numbers that are not 0 or anything, then you just put k for v. That's case number 1. Then case number 2, if f of x is equal to, let's start by putting an exponential thing. So it is equal to something which is exponential, ae to the alpha x. Then that means your v is just going to be equal to, all you're going to do is you change this number. So if it is an a, you are going to put something else. Maybe we can say it is, let's just call it b e. So in here you just say for your v, you just say a, you put an a, but you bring back this part being exactly the same. So it'll be e to the alpha x again. But now you just have to find your a, because it will not be the same number as the one that will be there here. Okay? This is, remember, f of x is what will be on the right-hand side. F of x, this is the right-hand side. This is the right-hand side. If the right-hand side is something exponential, bring it back. Bring it back for v. But then just change this, put an a. Don't bring it back exactly as it is. Bring back everything exactly as it is, but just remember to put an a instead of whatever number was there. But in terms of the exponential itself, bring it back. If it was e to the 2x, bring back e to the 2x. If it was e to the negative x, bring back e to the negative x. Bring it back. Then, this is easy. You can see how easy it is, eh? What about, you say to me, what about if f of x is going to be equal to a trig thing? So if it is equal to sine of, ax plus b, or, sine of ax plus b, or if it is equal to cos of ax plus b, or if it is equal to sine ax plus b plus cos ax plus b. We don't care whether the thing will actually come out to be a negative or positive, whatever. When you get it like this, you are always going to put your v being equal to. Look at how you're going to put your v. You have a sine ax plus b, and you have a cos ax plus b. For b, you bring it back. But when you choose your v, you're going to bring back a sine and a cos together, and the sine and the cos together should be adding. So you're going to bring the sine and the cos together, but they should be adding. So in here, it could have been, you're just going to put a sine ax plus b plus b cos ax plus b. Okay? Like that. A sine ax plus b cos ax plus b. Clarify. Am I going to do this if I get a sine only? Yes. If I get a cos only? Yes. Even if there was a number here, ignore that number, okay? Even if there was a k or whatever, ignore that k. Ignore it. Whenever you just put an a, you're going to need to look for the a and the b. So let's talk about it in simple terms so that we all remember. If you get an exponential, bring back the exponential. We brought it back. But when you bring it back, put a constant which you are going to have to look for. In here, we're putting a constant which is called a. So when you bring it back, put a constant which you're going to look for. If you get a trig, bring it back. But when you bring back the trig, if it was a sine only, you come and put sine and cos both. So, and this inside should not change. The inside should not change. But what you must do now is just put an A and a B outside. And those are the ones you're going to have to look for. Last two cases. Let's talk about it. Case 4 is, what about if you get a polynomial? If f of x is equal to, let's just say it is equal to, let me put it, ax, let's say a plus bx plus cx squared. Whatever it is equal to a polynomial, you will choose v being like the same thing. Your v is going to be the same thing. Usually here they put a big A plus bx, let's just say that, plus cx. You choose your v being the same thing, but then if your polynomial was ending at x squared, bring it back. But remember, the only thing we never bring back is a constant. So the values here are going to be the ones that change, but we'll bring back the number, the x and the x squared, but the values which are the ones that will change. So for us, we'll write to say we'll actually have small a plus a bx plus a cx squared. Then we will need to look for this a, this b, and this c. But we bring back, if it was just having an x here, then we'll just say it will be v is equal to an a plus just something with an x plus bx. Then we'd look for it, okay? So that is what we do. We never throw away. This is how it's going to be for us. You see, this can be hard. There's no table to cram here. Where's the table? There is no table to cram. Exponential, bring it back, but put an a. Constant, choose your v being k, and or a v being kx. So this part is depending on your ability to choose v. Can you choose the correct v which you will look for? If you can, salute. You're going to solve. We have it again here. A sine ax b, but you are now needed, you will look for this a and the b. But choose the correct v. V should be equal to this then v. What about the last one, which is actually the common one? So if f of x is equal to sum, what do we do when it is sum? Let's say it is exponential, it is trig. What you're going to do, v will also be sum. Just bring back the things. But remember, when you're bringing back the sum, just change constants. For v, you bring back the sum, but remember to change the constants, which is 9 times out of 10 the one which comes. So you should know case 1 to 4, and you can be able to do the sum. Let's go and let's see how we actually solve it. I'll redo this one with you again after solving. Let's go and let's solve. What we have seen is, if you have the right side being a number, then you choose v being, for v, what are the things you put for v? Either you make v be k or v be kx. If the right hand side has an exponential, what do you choose for v? You say let v be exactly this thing, ae to the alpha x, exactly that, right, that. But remember, your alpha will actually be something. It could be 2 or whatever. Bring back, but you should put this a. That's the one you then look for, the a. Wena, that's going to be your job, okay? But the exponential, you bring it back. If v is a trig, you bring it back, but you now will have a new a and b, which you're going to need to look for. If you have it being a polynomial, you bring it back, but you are now going to have new values to look for. If it's a sum, you bring back the sum. Then you'll be finding whatever is missing. Are we scared? No, we're not. There's nothing to be scared of. Let's go and let's cook. Let's do questions. Remember, this is the last one from test 1. What does it say? Find the particular solution of the following linear second order differential equation. Find the particular solution. Blah, blah. don't read the question, okay? You just see it say find solution, and then you see second derivative, and you see it is not equal to 0. Really? Yeah. There's second derivative there. And they're actually telling you it's an ordinary differential equation, which means it's part of the 4 methods which I showed you. And here they are showing you that it is not equal to 0. It is equal to something which is not 0. Oh. Ah. I'm going to solve it in 2 parts. My y will actually be complementary function, which is u, plus particular integral, which is v. And remember to add. Now, how do you get complementary function? You ignore this. You act as if it was equal to 0. Then how do you get the v? You will now work with this part, but there will be a v, and it is equal to that. Then you choose something for v using those cases. You just need to choose the right v. Choosing the right v, yes. So that's all you have to do to find v, yes. To choose the right v, yes. By looking at what is there on the other side, yes. Ooh, this one actually brought a product. Wow, man. I thought it was going to end at sum. This was actually product. When they give you product, let's see. This is the only product they'll actually give you. If you go through your table, you see that they'll talk about it. It's the very last thing where they say, what do you do? But I'm sure in the test it was a sum or something. You look at the v. What do you mean? You say to me, clarify, what are you talking about? What do you mean by product? We have exponential, e to the x. Then we have cos 2x. And they're actually not adding, they're multiplying. So this is a product. And we know if we had our thing being equal to e to the x, then, or maybe 3e to the x, then for v we were just going to say v is a e to the x, because we said we just take this, but we'd put an a. Then for cos 2x, we know what we would have done. We would have said v is equal to, would now say a cos 2x plus b sine 2x. That's what we would have done. Then we would try to look for a and b. Really? Yeah. We said you bring back the trig, but what changes is the constants. There will be now an a and a b, which you'd need to find. Here you bring back the exponential, but what changes is there is now an a and a b, which you're going to need to find. That's what changes. Finding a and b. Simple. Oh my gosh. Choosing v, you can choose v, man. Let's put here where there is a product. Let's put the last case, which I thought 9 times out of 10, the tests which come, including the one we wrote, didn't have product. But this is going to be 6. Don't worry, we'll do all the situations. I know you are good at them, but you just need to see them being used in practice, then you understand. I'm going to do at the end just an exercise of doing different things where we choose v together, to say, let's choose v here, let's choose v here. We'll be choosing v's together just to make sure you are able to choose v, which is going to be the particular integral. V is just the particular integral, okay? And for this one, that's the one where you said you use the table. But we don't use the table, we know what to do. We know the situations. If it is a constant, we know v is k, if it was whatever. So because we don't want to cram a table, how do you cram a table? We know for polynomial, you bring it back, but what you change is you change the constants. For trig, you bring it back, but you change the constants, and they should be both a sine and a cos. Even if it was just a sine, it should go to be sine and cos here. But what will change is the constants outside, but the things inside your sine and cos is the same. It will be exactly the thing that was there here. That is what will change. Then you find the a and b. That's how you find your v. This is how you choose v. You can choose. Come on, I know you can. Now let's do this last situation here where you have a product. So if f of x is going to be product, and for product it is always that case which you had, it is going to be e to the x multiplying some trig of x. Okay, let's just say k e to the, we have our f of x being k e to the whatever, multiplying here. So we'll put in here sine x. Let me try to see how it exactly it was in the table. Give me a second, and make sure that it's correct. But this is like the last situation which you'd get. Give me a second, let me go, sir. Okay, yes, here they gave you, and even if it was a sine x or sine 2x or whatever, let's make it a sine 2x. This is an example. You have your, in the other side, you had many, many, many things, and they were equal to this. You had your second derivative plus blah, 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 your first plus blah, 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 and they were equal to ke to the x sign. So here, once you see this, that means it's the product. That's the last situation. For your v, what you do is ignore this k. You bring back e to the x. Then, inside, that is when you bring back this. But when you bring back this, remember you bring back the sine and cos, but remember there will be now a constants to find. So it's like you say a cos 2x plus b sine 2x. Then you'd need to find your a and b. You'd need to find your a and b, and that is what you have. You ignore this k. K doesn't even matter. But you bring back e to the x. Then inside, that is when you say, you put new constants. No matter what number was there out here, we don't even care. That is what you now do in the second step when you are now finding particular integral. After finding the first thing, which is the complementary function, then you add them to get y. Y will be complementary function plus particular integral, which is u plus v. So let's find the u and let's find the v. We know how to find the v. It's by knowing these conditions. It's by knowing these conditions. And if we know these conditions, we are good. Let's do this one. Let's find our v. Let's go and do the question. So you get a question, and your question is actually this one, the last one from this assignment, the last big calculation question from this assignment. Emath, we are coming for you. We are coming for you, mister. Let's go for Emath. d2y dx squared plus 2 minus 2 plus, then this is going to be 3e to the whatever. 3e to the x cos 2x. 3e to the x cos 2x. So it is actually equal to 3e to the x cos 2x. Here we actually had it as the second derivative with respect to x minus 2 times dy dx plus 2y is equal to. This is what we had. I think it was 2's. If I remember well, it was a minus 2 and a plus 2. You always want to be sure because you don't want to work all this time and you're doing the wrong question. That would suck. We're actually correct. So this is what we have. This is actually what we have. Now, let's solve it. Let's solve this small boy. What we do is we ignore this. We first make it equal to 0 so that we find our complementary function. So for you to find that, you are not going to use y, but you're going to use u. So you're going to say let, if we can put it, would say del 2u del x squared instead of dy minus 2 du dx plus 2u be equal to 0. So this is going to be for what? For complementary function, the first thing. We ignore the, wherever there is y, we remove, we put u. So del 2y, it becomes del 2u. dy dx becomes du dx. Y becomes u. But it will be equal to 0. That's the first part. We find u. We make it equal to 0. And when it's like this, we know how to solve anything which is equal to 0. That's the one we did in the previous example. The one which was equal to 0, we did it in the previous example. All we did was we used the d operator form. We know that the second derivative is actually d squared, and it is of u, minus 2, then here it is d of u, then plus 2u is equal to 0. Then what we do, we factor out d, so it's going to be d squared minus 2d plus 2, and this is of u is equal to 0. So we have the d operator form. It's the same thing we did. But only that for here we are doing for u. And when we do for u, we have the first part, the complementary function. Then we go back to the original thing again, and we are going to remove y and put v. But when we put v, we won't make it equal to 0. Here we put u, we removed u, we had this, we removed everywhere where there was y, we put u. But once we did that, we removed this whole thing and we made it equal to 0. We find our u. Let's find our u. You know what to do here. From here, what do you make? Here it's equal to 0. This is the d operator from. From here, you take auxiliary equation. You just take the things inside the brackets and you put them in terms of m. Okay, so you're actually going to have m squared minus 2m plus 2 is equal to 0. Then what you're now going to do, solve. You find your a is 1, which is the number before m squared. Then you get your b is the number before m, which is negative 2. Then you get your c is the constant which stands alone, so c is 2. You have your 2. So now you have this, you're solving this equation, and you solve it the way we did that one on top, the previous one. The previous one, which was equal to 0, that's the way we solve this one. So we create one way which is equal to 0 by putting u where there is y. That is called complementary function, and it actually works. So here we would now say, first thing, b squared minus 4ac. This is equal to b is negative 2. So it's negative 2 squared minus 4 by a by 1 by c by 2. So it becomes negative 2 squared is 4. Minus 4 by 1 is 4 times 2, that's 8. So it's 4 minus 8, which gives us negative 4. So now you're going to say that means my m is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You are not running away from the quadratic formula. Make sure you can do it in your sleep. It will cost you. So this will actually be negative of b, which is negative of negative 2. Is it negative? B is negative 2. Yeah. Then we say plus or minus the square root of negative 4 all over 2a, which is 2 by 1. You get it as m is equal to minus or minus 2. That's 2 plus or minus the square root of negative 4. That means of negative 1 by 4 all over 2. M is equal to 2 plus or minus the square root of negative 1. We know what it is. I squared is negative 1. So it is going to be I squared by 4 all over 2. There we go. So we are now saying m is equal to 2 plus or minus the square root of 4i squared. The square root of 4i squared. The square root of I squared is I. Square root of 4 is 2. So it is 2 over 2. Which, if we factor out 2, would say m is equal to 2 comes out. We remain with 1 plus or minus I all over 2. 2 into 2, they cancel. So we can now have m is equal to 1 plus I. Then that will be m2 is equal to 1 minus I. And we have the two solutions for m. Now when you get the two solutions for m, you know what to choose, but we are no longer choosing an answer for y, we are choosing for u. These are two complex solutions. So we know it will be e to the alpha, which is this number, e to the 1x. Then you're going to say a cos beta x. What's the beta? The number before I, that's 1. So a cos x plus b sine, the number is just the 1, plus b sine x. This is going to be my u. And you are done. I know that when we got here for y, we then looked for a and b. But for you, don't. Just get u. Remember that we had said that that thing will be equal to e to the alpha x, which our alpha was just here. It's 1. So, anyway, this is u. What do we do now? We rewrite the original one again. But where there is y, we are now putting v. Because we now want v. Then at the end, you just say y will be u plus v. Which is this u, the complementary function, plus v, the particular integral. And how do you get v? Using the things we just did. Using the things we just did. Don't let it be hard. It's not hard. So we'd say, okay, let's rewrite that thing which we had. The same animal, but we would then change the y and put v. wherever there is y. That's where we are changing. So let's go. Let's change. Del 2y del x squared minus 2. So we're going to say, okay, d2y dx squared minus 2 dy dx plus 2y is going to be equal to e to the x. Is it sine or cos 3x or something like that? 3e to the x cos 2x. So it is equal to now let's quickly do it. So we're going to say d2v dx squared minus 2 dv dx plus 2v is equal to 3e to the x cos 2x. You say, what? Yes. Remove y and put v, please. Do that. We're not even integrating. This is like a joke. It's like playing games. You should be able to do it. So now this, the second derivative, it will be now d squared of v minus 2d of v plus 2v is equal to 3e to the x cos 2x. Let's factor the v outside now. Uh-oh. No, it's okay. Nothing crazy. D squared minus 2d plus 2v is equal to 3e to the x cos 2x. Wow. Really? Yes. Now, this is the time where you replace your v. Looking where? Look here. Look on the things that are on the other side. You see it's a product. You know what you do for a product. Ignore the 3. We never ever bring back constants. Ignore the 3. D squared minus 2d plus 2. Instead of v, we are now putting what v is. What is v supposed to be in this case? It will be e to the x. You bring back the e. Then you now say inside bracket a cos 2x plus b sine 2x. You bring back this 2x here. But it will be now in both cos and sine. Remember, this guy is what we bring. This guy inside here, e to the x multiplying this. This is what we bring when we have a product this side. Oh, so that's what they actually meant by replacing v. Yeah. And this you just say it is equal to the right-hand side will never change. 3e to the x cos 2x. But we have replaced v. That's the job. That's the main job. Doing the particular integral, this thing where you should replace v, it's depending on your ability to replace v. Replace v, replace v, replace v. Okay? After finding u, of course. If you're cooking this one, you're good. So, okay, now the game is just we have to find the solution. So we have to find the solution, and if we can find the solution, we need to find the a, and we are going to need to find the b. Okay, so let's do it. This is going to be let me just see some. Give me a sec. Okay, let's finish it. Something important. Let's finish it. So what I was confirming something which I thought is important. Let's now do this and let's see how it goes. So what we'll do is this is an expansion, but this is a little bit longer. Let me just see if I'm going to do this. Where is an exponential? I don't want the exponential product. This is the sum. Yes, here we have the sum. This is equal to, yes. Wow, it's actually long. Right, let's go because I saw it exactly as it is in one of the books. I didn't want to know. I wanted to know if I should do the long thing. Let's go for it. Here now, when you're just going to compare things, but don't think it's going to be short. You have replaced your v. Now, what you should do is you should know that d squared. We know what it is. It's second derivative, right? And then d is the derivative. Then this is just 2. So I would have to say, I should now say that. Let's expand. I would say d squared is going to multiply this. Negative 2d will multiply this. 2 will multiply that. So first I'll and when I get all those answers, I'll compare them with the right hand side. And then I'll be just seeing solutions. So it's like I'll say d squared of the whole thing. E to the x multiplying a cos 2x plus b sine 2x. Let's find that. That's the second derivative, right? And I think for us to get the second derivative, we need to have found the first derivative. So we need to find the first derivative. Let's find it. If we say 2, we first have to find d. D of this, then we can find negative 2d. So d, what is d of this? It's just the derivative of this whole thing, okay? It's like you're saying d of this. Let's find d of all this. That's just the derivative. Derivative of this, obviously, I have to use the product rule. Remember when you write, sometimes they like to write, when they write how you're going to convert this form when you choose your v, this v, they like to put sine x before cos x. It doesn't really change anything. To say b a sine x plus b cos, it's a 2x because this was a 2x. So a sine 2x plus b cos 2x. It doesn't change anything. So you'd say, even if I said a sine, so let me change the order just so that you can be able to, a sine 2x plus b cos 2x. We find d of that because everything in the first bracket is multiplying everything in the second. Then we'll find d squared of that. Then we'll multiply also by 2 and we'll find all of them. Then we combine them. We'll actually add them and we compare them with the right hand side. So we'll be seeing what your A, your B, your C will be. Because the job is actually to find the A and the B and the C. So all this part will be giving you a whole lot of marks now. So you'd be saying, okay, I would now say d of this. This is an exponential multiplying a trig. This is a trig in this bracket. So you're going to use the product rule. So the product rule will say if you're differentiating two things multiplying, so this is your u and your v. When you're differentiating, bring the second one as it is. So first it will be a sine 2x plus b cos 2x. We brought it as it is. Then it will be multiplying the derivative of the first. The derivative of e to the x is just e to the x. Plus, you now bring the first one, e to the x. It now multiplies the derivative of this second thing, which is multiplying it. The derivative of this. The derivative of a sine 2x. We're now putting the derivative. What is the derivative of a sine 2x? A will come back because it's just a constant. Derivative of sine 2x, you should know the table. Y dy. If you differentiate sine, you get cos. If you differentiate cos, you get negative sine. So you'd say the derivative of sine is going to be cos. But if it's a sine 2x, it would be 2 cos 2x. Okay? So the derivative of sine 2x is 2 cos 2x. So it will be 2 by this a, it will actually be 2a cos 2x. Then you now say plus, here b is still b, but the derivative of cos, derivative of normal cos is negative sine. If it's a cos 2x, it will be a negative, then instead of sine 2x, it will be 2 sine 2x. And because there's a b, it will be negative 2b sine 2x, like that. It is now multiplied. So this is what we actually have. This is the second derivative. We are now doing things separately. Then we'll come back to this whole thing, okay? We're doing them separately, the d. So we'll actually get it as equal to, we will have e to the x, it will multiply a sine 2x plus b cos 2x. Then we have plus e to the x, it will be now 2a cos 2x minus 2b sine 2x. If we are going to say what is negative 2d, negative 2d will be just equal to negative 2 by everything. Okay, so it'll be negative 2e to the x, and then in brackets you have a sine 2x plus b cos 2x. Then you're going to have again here negative 2e to the x, then it will be 2a cos 2x minus 2b sine 2x. There we go. Now remember, when we have the d, we will rewrite it, the d, to say d is equal to, because we will need the d squared of that same thing, d of this. You can rewrite it so that you can now have the d squared of that guy. So if you want to say d of e to the x, a sine 2x plus b cos 2x is actually equal to, the derivative of that is actually equal to, we got it here, e to the x, a sine 2x plus b cos 2x plus e to the x, 2a cos 2x minus 2b sine 2x. It's now just finding these d primes, these d squares and the whatever, so we can equate. But you've put your v, you've put every, you're now just finding these things. So you equate and you find your a and your b, the missing constant. So you'd now say, okay, let's find our d prime prime, or d squared of e to the x, a sine 2x plus b cos. That means we are differentiating it again. The second derivative. We would now come to this first derivative, and we are differentiating it. So we differentiate this. And since we want to differentiate this, we know what it was when we differentiated it here. How does it do? It will come back, but it will also bring this one with it. Okay? Then now we will differentiate this one separately. So the derivative of this first one, we've done it before. It brings itself back, then it brings this one back. Then we'll do the derivative of this one, we'll see what it brings. So for here, it will be e to the x, no need to think, a sine 2x plus b cos 2x. Then you say plus e to the x, 2a cos 2x minus 2b sine 2x. Then you now say plus, now we are going to differentiate this. And when we differentiate this, what do we know? You bring the second one as it is, 2a cos 2x minus 2b sine 2x. Then you multiply by the derivative of the first, by e to the x. Plus, now what do you now bring? The first one as it is, e to the x. Then you now multiply by the derivative of the second. So the derivative here will be, we differentiate cos, it gives us negative sine. So if it was a cos 2x, it would give us negative 2 sine 2x. But that negative 2 will multiply this 2a, it becomes negative 4a sine 2x. Then minus, here we have 2b sine 2x. Sine 2x just gives cos 2x. But if it's a sine 2x, it will be a 2 cos 2x. So in here, it will be multiplying that 2, it becomes negative 4b cos 2x. Then we can equate. This is what we had for our d squared, man. This is what we actually had. Then we can see for 2 times this, you then bring it back. So you'd say plus, you now say 2 by e to the x a sine 2x plus b cos 2x. This is going to be 2e to the x a sine 2x plus b cos 2x. Now find the things. Find the constants. It is equal to this 3 blah 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 blah. So, wow. This was hard work. But if you have done all the steps up to here, you have a lot of marks. If you've done all the steps up to this stage, so you now have a lot of marks. Of course, now you are adding this and you are making it equal to this. You are making it equal to that. So you can try to see what it is. And we'll be trying to find your A and your B. I'm going to leave it here because I feel like if you've gotten to here, you've got it all, a lot of the steps. You lose the 1 mark or whatever for getting the NB, but you have done all these steps to actually get the D squared and the 2D and the 2 of this. Yeah, you'll be good. Remember, D squared is second derivative of this. D is the derivative of this. We got them, and yeah, these are marks. So that'll be good. And when you have done this, you are done with ordinary differential equations. So this was the very last one. How good is that? Makes you feel good? Makes you feel good. I'll give you a nice 10-minute break to process all these methods, and we will go again. We will be now going again into the things for assignment 2. We try to finish, then we can do questions. I know a lot of you have seen a lot of things that can help you right now already. So let's just have a 10-minute break. Yeah, 10. What is the time? 7 minutes to 10. So yeah, I'll put the time to come back on the board. Then we resume. So take a break, move around, do your thing.